So I just did my first shake on it last night. That was good.
Go to that button.
I think I grilled out last night.
I didn't really give you much more room for
My wife went shopping. We're here last night. Okay.
See, that's what you call timing. I got everything ready just right. Well, I'm 6 minutes late. So, all right. And we,
7.5.
yeah, well, you know. All right, welcome everyone. So thanks for coming. So real quick, couple things. So one, I want to thank Slingshot. See, I'm looking at the Y. And I'm like,
I know.
Why?
It's okay.
Well, I honestly, what first came to my head was Yahoo, and I'm like, it's not Yahoo.
I'll let Dave know that. Change our, we'll have to rebrand.
I actually kept thinking it's like, were you part of Y Combinator's, one of their startups?
I'm actually wearing the right color.
Yeah.
Well, it's a Slingshot. And
Yeah, I get it, yeah.
Yeah, it just needs the string hanging off of it.
What you really need to do is get that Jorgen Sprave guy that has the slingshot channel on YouTube that does all the crazy stuff with like the knives and slingshots to do a commercial for you. Yeah, it'd be great.
So
Sorry.
So sure enough. So Slingshot, they sponsored the space. Tech Systems sponsored the food. So definitely want to thank both of those. So upcoming meetups, because we don't care about guys, we care about the upcoming stuff, right?
As you should.
Well, it's because it's easier doing this now than after his presentation. So next month, I'm going to do a talk about essential software design patterns. Actually, you're all my guinea pigs, which works really well. Because I have a couple of conferences coming up that I'll be doing that presentation, so that helps with that. In June, we're going to have Mike Eaton coming down about building awesome console applications. Someone made a comment that, because I actually posted this picture today, shouldn't she look a little bit happier? Actually, my thought was, see, she's not building, awesome applications yet.
I just thought that was Mike.
No, it's not Mike.
Is that a Commodore 64?
No, but it's supposed to be retro. I will say I was looking for like a heavy metal reference.
Oh, yeah.
And I just couldn't find anything. In July, we're going to have David Yard come in, and he's going to talk about empowering AI. So it's going to be a pretty salesy talk about all the AI tools that Microsoft has. And I will tell you in August, I just don't have a slide up for you because I don't know what they want me to do yet. But we're going to talk about AI again. It's 2024. AI is the thing. But Microsoft's they're asking MVPs to do a session about AI. But they're going to have prizes for everybody. So it should be swag in August. Which reminds me, I talked about the August date.
Okay.
I need to change it. So there's also Azure meetups. So, obviously the March one's taken. I just realized I didn't have the April one. I do know there is something for scheduling for April. I cannot remember what it was. But we do have everything scheduled through July right now. And the title's not Azure Functions, but it is about Azure Functions. I know because I'm the one doing the talk. Sure enough, Azure Functions, they announced this in Ignite, but they're going to go public preview. Right now, it's a private preview of flux consumption, which is really, really darn cool. So it's a whole lot faster and spins up really, really fast, and it's going to be cheaper, which is always nice. As far as upcoming events, so Star Trek up in Guy's neck of the woods. Are you speaking of Star Trek?
I am not.
Okay, neither am I. But that'll be May 3rd. Definitely. Are you speaking of Star Trek? I'm not speaking there, so I don't remember who all is speaking. I do highly recommend.
Clearly, no one important.
Exactly, right? I would not be there because it's kind of hard for me to go to events I'm not speaking at. But I do highly recommend it. It's a lot of fun. It's at a movie theater, and at the end of the day, you watch a movie. And this year they're watching The Phantom Menace, which sounds kind of weird, but it's actually the 20th, 25th anniversary of
25th.
Phantom Menace.
25th.
I knew it was the
I don't
20th or
wanna
25th.
think about that.
Hmm?
Just the fact that that's that long ago that came out.
Misa want to speak at Star Trek?
So some other upcoming things. In June, you've got Scenic City Summit, which is down in Chattanooga. It's actually a really nice, smaller event. Cincy Deliver, I highly recommend Cincy Deliver. Are you?
No, I'm not.
No, I know you are. I should know whether or not he's speaking. I'm actually the one who picked all the sessions. So you would think I would know all speakers, but I don't. But we do have a really good selection of speakers. And that's run by Phil. I helped Phil out with that. And then,
Where's it at in Chattanooga?
sorry,
Where's it at in Chattanooga?
the one in Chattanooga, it's this year. It's at the Marriott, I think. Last couple of years, it's been at the convention center, but downtown.
Yeah,
So-
Chattanooga, Marriott, downtown.
Yeah. And then a little bit further out in August, I forgot the dates and I was in a rush. But you got DevUp, which is out in technically it's St. Charles, but St. Louis. And that's always a great event. Although really weird. I was looking at because they announced the sessions today, and so I'm doing a workshop, and my workshop is basically building serverless applications .NET. I also noticed on the same day you've got Phil's going to do a talk about building. I forget the exact titles, but basically building web applications using Blazor. Woody's up there. He's going to talk about building web APIs, and there's someone else who's also doing basically C# web applications. I'm like, so you've got four of us who are doing different workshops. So a plethora of choices, or a conference organizer who can't say no. So, all right, I meant to put the logo. So I'm assuming we're going to go to I forget the name of the place. Brick Tavern. Everyone liked that last month? Well, so we're going to go to Brick Tavern. It's down, or Brick House Tavern. Yeah, it's just down the street.
Cool.
Again, we just moved this location last month, so we're still trying to refigure out things. So we'll do that afterwards. All right, finally. So we've got Guy. So probably can tell I've known Guy for a while.
Yeah.
We're pretty chummy. We hang out a lot at conferences. Kind of weird. .NET, and we got JavaScript. Actually, even funnier. When I was putting the session for next month, I forgot to change the title. So at first it was JavaScript, and you could know it was wrong because Chad Green is not talking about JavaScript. That's for sure. But here's the thing. He's going to be talking about vector search, which is, if you think about AI, that's what vector database is what that's all about. So even though this is JavaScript, this really applies a lot with what we're doing, right? And Guy is .NET friendly. He just doesn't do .NET.
It's actually on my one of my goals this year is just to get deeper into the .NET stuff. I did .NET at the very beginning,
so
like when it
instead
was
of
brand spanking new.
So instead of hiring a .NET guy,
Well, I was trying to, full disclosure, I was trying to bring Chad onto the team, and it was like, we need a .NET guy, and they're like, well, you can learn .NET guy, and I'm like, why have a .NET guy when you have a .NET Chad?
so hence my little joke about
But he ended up at a fantastic place. So.
Yes, I'm having a great time right now. All right, and the switch is over.
Okay,
All right, you are now sharing.
All right, so. I think I'm going to stand up. I feel funny sitting down. I will have to sit down eventually because I have a demo which has lots of code, and it's easier to use my fingers to navigate stuff than it is to try and use this to navigate code. For now, we'll stand up. Hopefully the audio comes through okay if anyone is watching us on stream or watches the YouTube video later. So, I'm loud, so it should be good. So welcome, everyone. My name is Guy Royce, and this is you get the first version of this talk with slides. I've given this talk a couple times, in Columbus at the Columbus JavaScript meetup. I gave it at Columbus Java user group. So I did it first in the place it belonged in the JavaScript meetup at Columbus JS. And then I did it at a Java meetup. And I apologized profusely. I told them that this is the scripting version of Java, and they were good with that. Now I'm going to do it at the .NET meetup, and next I'll do it at a Python meetup, and then I'll hit all of the. That'll really offend everyone because we're talking about vector search, and we all know that the only way that you can do anything with AI, including vector search, is with Python, right? That's why we're going to talk about it at a .NET meetup using JavaScript. So this started out as just a sample project that I put together. I was literally tasked at work with creating a sample application showing how to use Redis's vector search capability with JavaScript. And so I, of course, couldn't do anything boring like, like a bookstore or something like that. I had to use Bigfoot. And so I had created a Bigfoot themed application that lets you find Bigfoot using vector search. And I wrote it in JavaScript because that's what I was told to do. And then I'm like, well, I've got this code. Let's put a talk around this. And so this is that talk. This is the first version, like I said, with slides. Come on. There we go. Gonna go. There we go. There's the slide that has all the info about me that you would ever care to know. There's my title. I'm a developer advocate. Actually, a senior developer advocate. Look at me. And but I took the senior out of it because then I put the name past the edge of the profile photo, and I thought it didn't look good. And I don't really care about titles that much anyhow, honestly. It's got my name there. And more importantly, it's got things that matter to you and things that matter to me over here on the right. We've got my X profile there. Currently, Twitter, currently known as X. If you want to give me a follow, if you still use that platform, maybe I'll break 4K. I'm at like 3,995 followers. And if 5 more people just sacrifice their morals and get on Twitter, X, then I could reach my goal of 4K and die happy. The thing that matters to me, the thing that matters to you more importantly is github.com/GuyRoyce. The code for this is out there. It technically lives on Redis developer, but I've got a fork of it on Guy Royce, and these slides and everything will end up there eventually. So that's the thing that you really care about. And if you really want to go see a blog post I wrote 4 years ago, you can go out to guy.dev. So that's enough about me. Well, actually, no, it's not, because this is a statement about me as well. It's actually very important because we're going to be talking about vector search, and vector search is a AI data science machine learning kind of thing. And this makes a statement about me in regards to that. Any guess as to what that might stand for? Clue: it does not stand for Iowa, and whatever that says. Any guesses? I'll let it hang there for a moment, and then I'll answer.
You do understand that, and I'm not going to say it loud. NADS, that is code for something.
It is. It's way better than the I am not a lawyer one that I see people use, which looks like a really crappy .NET interface. This stands for I am not a data scientist. So I'm Guy Royce. I'm a developer. I've been writing software for 30 years, lots of different stacks, lots of different technologies. Actually did .NET in the early 2000s when it was brand spanking new. But I'm not a data scientist. I don't have the math background. I just don't spend my days looking at the calculus and the theorems and the proofs and all of that stuff that make data science do the data science stuff. I'm a fan of data science. And so what I like to do as a fan is I learn about things. And as I'm learning about them, I get excited and I put together a talk. And then I subject you all to it. So thank you, subjects. So I'm not a data scientist, but I think it's cool. And I'm going to share what I've learned so far. There could be flaws in what I tell you, so don't trust all of it. I will say that the Redis bits are probably accurate. Maybe I may be oversimplifying, but there's a key thing about the data science bits that we as developers need. How many here would say that you're a developer? Probably everyone, right? Anyone here a data scientist? So what I meant to say is that I'm an expert and you should believe everything that I say. No. As developers, we don't need to be data scientists. We need to use the tools that data scientists have created for us. And so we can take these models and use them and compose them and build applications around them. And we need to understand them well enough that we can use them and understand why they behave the way they do empirically. It's sort of like if you were a mechanic, you need to understand how engines work in regard to, hey, if the fuel mixture is too rich, then that's bad. And if it's not rich enough, then that could be bad, and understanding why that matters. But I don't need to know the chemistry of how gasoline and oxygen combine at a low level. I don't need to be the engineer that designs an engine. I'm the developer. I'm the mechanic that hooks things up to an engine. And so that's a lot of what we're doing as developers with these data science tools. So I approach it from this point of view. Maybe I'm lazy and I just don't want to learn math. But I think I'm probably not alone in that. And I actually find this comforting as a developer because there's a lot of fear around this stuff, right? The AI is going to take my job and I don't know how to do all this stuff. I need to be a data scientist in order to stay relevant. And I don't think that's necessarily true. I think we need to know how to use these new tools that are coming out. There may come a point, hopefully after I retire, where the machines can just do everything and we're in a post-scarcity world and we're all on UBI and it's great and I can just play ham radio and Dungeons and Dragons all day. But until that day, I'm going to compose models to make cool applications. So that's how I approach this data science stuff. In addition to not being a data scientist, but being a fan of this cool tools and as a developer, I'm also an enormous fan of Bigfoot. We all, I mean, who doesn't like Bigfoot, right? For me personally, though, there's something extra special. There's something about this large, robust, hairy person that, this hominid, two-legged guy out in the woods all day. There's just something that resonates about that with me. It's something about Bigfoot that I feel like I can relate to. And, well, I have to confess, Bigfoot is my father. And that did not come through there we go. Bigfoot is my father. I actually haven't seen him in a while. He left when I was a kid, went out, said he was going to go buy milk and cigarettes, never came back. And as you might imagine, he's kind of hard to find. But I've been trying to find him for years. And so I did what everyone would do if they're trying to find someone that's elusive. I hit the stacks. I went and looked at all the reporting, all the documentation, all the hard-hitting reporting on Bigfoot. I went through all the periodicals. This is from the weekly World News. You perhaps know this publication, this bastion of journalism. They have dozens of witnesses seeing a Bigfoot roaming the wilds with a human child. That's me right there, an artist's representation of me in my whitey tighties running through the woods with my dad. You can tell this is a solid journalism because they've got an article on here. The study claims that smoking makes you ugly. And these people who are allegedly zoologists are very serious-minded looking people there. So this is clearly an article. However, this didn't really help me find my dad because, well, it told me where he'd been, but it didn't tell me where he is. So how can I use that to find him? Well, I decided instead to go to the experts at the Discovery Network. I don't think this show's on the air anymore. I've had the slide for a few years now, but you might remember this show. Anyone remember this Finding Bigfoot show? Had the four people that were trying to find Bigfoot, but somehow never managed to. I actually love this photo because they set it up to have three true believers and a skeptic. Any guess who the skeptic is? Here's the hint. She has a look on her face that says, "My God, what have I done with my career?" I really like this photo, though, because it's just the looks on their faces say a lot. So the guy on the left here is trying to look thoughtful and pensive. He's taking this seriously. Like, yeah, Bigfoot. The next guy, he just looks stoned. The woman in the middle, the skeptic, like I said, she's sort of questioning her life choices. And the guy on the right is really happy to be here. And as it turns out, actually, the guy on the right, even though I went to Discovery and I didn't find Bigfoot that way because they didn't find him, the guy on the right is the president of this group called the Bigfoot Field Researchers Organization. This is a real organization established in 1995. They are the only scientific research organization exploring the Bigfoot Sasquatch mystery. And I looked at this and I said, this might give me the data that I finally need to find my dad. They have a comprehensive sightings database, but it wasn't really a database. It was a bunch of ASP pages, not even ASPX pages. So, those ASPX pages or ASP pages were just, they were for humans to read. They were unstructured. There were some of the data on there was like, basically table layout. Here's the date, here's the ID, that kind of stuff. But it wasn't anything that I could like go in and query easily. And I wanted to bring this into a database so I could query it, both the structured data and the unstructured data. And so, fortunately, the internet has everything. This is Tim Renner. Tim is my personal hero. In addition to providing this wonderful data, he's provided lots of wonderful data. I've got a ton of mileage out of it. Tim is a self-professed lover of weird data. He has screen scraped the BFRO's website and put it into a CSV file. Now I've got data that I can load into something and start doing queries against. And he did it to try and figure out where Bigfoot was at as well. Like, where can I look to find Bigfoot? And what he did was he took the latitude and longitude of all the sightings, plotted them out across the United States, and then did a basic clustering algorithm against them and found the natural groupings. And he learned that the natural groupings tend to correspond with areas of vegetation, which is to say that you can find Bigfoot in the woods. Like I said, he's my hero. He's doing the Lord's work. He also has screen scraped haunted places index. So there's a whole data set of haunted places. I haven't used that in a talk yet, but I kind of want to take all the ghost stories and shove them into LLMs and embeddings and do a bunch of AI stuff against them, a bunch of vector search against them. I think that would be fun. Although I will recommend something, I learned something really interesting about the haunted places data set, which is like you load these things into them and you make them searchable. And your first thing you want to do is like, well, let's look up my hometown. Don't do that. Not worth it. But it's a great data set. He also did the UFO sightings data set from the NUFORC, the National UFO Research Center. And they have 112,092 records of these UFO sightings. And he did great, important work with that as well. He did a histogram of the UFO sightings and learned that the most common day for a UFO sighting, what do you think it is? Any guesses? 4th of July. Because what's that, son? What's that, dad? Right? What's that up in the sky, dad? Is that a firework? No, son, that's a UFO. Right? Everyone's seeing strange things in the sky. Couldn't be a firework. It's totally a UFO. And about 80% of the UFO sightings, they showed up within 50 miles of U.S. airbase. So good stuff. He's doing really important work. And he's screen scraped all this Bigfoot data, and I can bring it in. The data is a joy to look at. They have these accounts. This is what the data looks like. So it's got an ID here. There we go. Let me use this. This will help everyone that's watching later. It's got an ID there, which is just a unique number. So you got like report 8080 here. It's actually supposed to be 8086. Typo in my slides. So that's just a report ID. So Bigfoot sighting 8086. I saw Bigfoot in the woods. They have a date associated with them. And they have a title. Here we have a series of large human-like footprints are found on a farm near Wayne National Forest in southeastern Ohio. We have an observed. This is the eyewitness account from the Bigfoot. And this is what the people who saw Bigfoot are saying. While during some yard chores, we noticed a series of tracks going into the hollow on our property. Upon examination, and then the story goes on. All Bigfoot sightings have a classification. They can be Class A, I saw Bigfoot. They can be Class B, I have evidence of Bigfoot, like a footprint. Or it can be Class C, someone told me they saw Bigfoot. The most verifiable of them all. You have a county and state that it occurred in. So this one happened in Noble County, Ohio. you got a latitude and longitude where it happens, and you've got location details. This is sort of the verbal directions of, go down near Harrisville, closest main road is State Route 145, right on the border between Noble and Washington counties. Tim, of course, didn't stop with his screen scraping this data. He went the extra mile. And he mixed in what was at the time the dark sky weather data. This is now defunct. Apple bought them, merged them with their brother product, and it's not a thing anymore. And so he went out and found that date, and he looked up the weather data for that date and shared it here. So we have like mid, high, and low temperatures, humidity and dew point, cloud cover, moon phase, all the things that you would expect to see from a weather forecast. So this is all the data about these Bigfoot sightings. So actually quite a bit of data. Now, some of this data, I kind of hinted at this earlier, some of this data is structured. Some of it is unstructured. Structured data are things like the temperatures. I could put a piece of structured data in a database and query on it very easily. Give me all the temperatures above 75 degrees. Some of them are strings. There's two types of strings. The string I'm talking about is something like the county or maybe the zip code, something that you're going to query in its entirety. Or maybe do like a prefix. Give me all the zip codes that start with 450. There are other types of strings which are text, which are a little different. They're unstructured. Or perhaps locations. Your latitude and your longitude is a location on the globe. You can query that in a structured manner. Say, give me everything that's within 50 miles of Cincinnati. Give me everything that's either where the state is Ohio or Kentucky. Give me everything where the temperature is above 75 degrees. Structured data, we know how to do this. We put these in relational databases and select star from where, right? Then we got unstructured data, things like text, the observed account, that eyewitness account, even the title, actually, for that matter, of the Bigfoot sighting is really not a string. I mean, it's a string in the sense that it's bytes, right? But it's not queried that way because you want to query it in an unstructured manner. Like you might want all the sightings where the title contains creek, but maybe creeks as well. You could have images. How do you query on images? You might have audio. You might have recordings of the noises that Bigfoot makes. I don't know what sound Bigfoot makes, but there are, the BFRO has several accounts where that's a Class B. They heard Bigfoot, but they didn't see him. Incidentally, this isn't a bit of an aside, but do you ever notice how Bigfoot's always capitalized? I guess the first letter of Bigfoot is always a capital B. It's like it's his name. Like there's one of him. I wonder what he sounds like. So anyhow, so you've got structured data, unstructured data. And searching structured data, as I mentioned, is fairly easy, as Jonathan Mills is going to show us here. With a relational database, I used MySQL style queries just because I'm doing a latitude longitude search, and each database handles that slightly differently. But the examples here are from MySQL, but you can substitute these for any database. Here I'm doing an insert into Bigfoot sightings, and I got my fields and I got my values, and so it's like I got my sighting ID and my high temperature and my state, my longitude and my latitude. So we know how to do this. We know how to shove structured data into a relational database, right? We've all done this. And then when we want to query it, we do a select statement. Select star from Bigfoot sightings where state is in Ohio or Kentucky, where the temperature is greater than or equal to 75. And this is MySQL syntax for querying a latitude and a longitude as if they're coordinates. And I probably have longitude and latitude backwards there, but forgive me. So this is how we search structured data. This is a pretty well-trodden path in technology. You can do this with Redis as well. I work for Redis, and so I'd be remiss if I did. The demo of vector search is using Redis, and so I thought I'd show how you can do structured data in Redis, and to insert things into Redis if you want to query them. Who here has used Redis? Just as a quick aside. So 2 of you, okay. So who has heard of Redis? I mean, besides me mentioning it right now. So what we do, this is a part of Redis. What do you think it is? Because I'm going to tell you, but I'm curious what you think. It's something the DevOps people talked about, right?
Solve all production problems.
It's often used as a cache because it's an in-memory NoSQL database. It's a memory-first NoSQL database. It is persistable.
So that's how I used it, because that's how they used it at, when I was at Composable Systems.
How do they use it as a
They
database?
used it as cache.
Yeah, caching is the most common use case for it because it's all in memory. However, it does write out the disk behind the scenes, so you can use it as a durable database as well. But because it's all in memory, it's stupid fast. And so usually Redis is used to solve caching problems, and caching problems are usually problems that how you solve crappy architecture problems. My application won't scale. Have you tried caching things? Oh, how would we do that? Well, you'd use Redis. That's a common solution. But behind the scenes, what Redis is it's a giant hash table. It's just a key value store. And one big hash table, the key names are just the entries in that hash table. The values in that hash table, in those fields, are the various data structures that you learned about in computer science class. They can be strings, they can be hash tables, they can be sorted sets, they can be linked lists, those sorts of things. And then you interact with Redis through a series of commands. The hset command is for hash set. It means set a hash in the key Bigfoot sightings 42069. And then here's a field value, field value, field value, field value. So this is setting an ID, a county, state, class, high temperature, and a longitude and latitude, or latitude and longitude for a Bigfoot sighting. And then if you want to query that, you can use the hgetall. And there's a typo in there. It's just hgetall. Ignore the set right there. And then you give it the key name. And that's a typo too. You are the first ones to see these slides. So I've messed a few things up, but it's not terrible. So this is just how you would insert and query things from Redis. If you want to search things from Redis, then you can create an index against Redis. So here we're calling ft.create. That means create an index. The index name is Bigfoot Sighting Index. We're going to do that on hashes. You can also do it on JSON documents. And that prefix 1, Bigfoot sightings : means look at any key that starts with Bigfoot : sightings : and if it's a hash, then read its contents and index it using the following schema. And here we've said if the field county is to be indexed as a tag, that means a string, like a zip code or a city or a state or a county. And the state and the classification, the high temperature, index that as numeric, and the lat long, index that as a geo point. That's a point in the globe. And then if you want to once you have this index created, you can call ft.search, and then you can do @key name : if you put it in curly braces, then that's querying a tag. So that says Ohio or Kentucky. If you put it in square brackets, then that is a numeric range. So we're going from 75 degrees to infinity. So that's 75 inclusive. So 75 degrees or higher, basically. And then our lat long, we also put that in square brackets. We give it a longitude, a latitude, a radius, and a unit for that value. So this gets everything within 50 miles of downtown Cincinnati. So this is how you can search structured data in Redis. It's not vector stuff yet, but we're getting there. Because the vector stuff comes up when we ask the question, how do we search unstructured data? There are two ways that we could do this. There are probably more, but these are the two ways I'm going to talk about. One is we can use full text search. If you've ever used Elasticsearch, that's what it does. Redis has a full text search capability as part of that search that I was looking at as well. And what we do with full text search is we take a document, a text, a corpus of text, like the observed of a Bigfoot sighting. And then we're going to tokenize it. We don't have to do this, but this is what the software is doing for us. And by tokenize, it basically means split it up into its individual words. We will remove all the stop words. These are things like a, and the, which are lousy to search on because they're all over the place in English documents. We're going to do stemming, which is take words that are grammatically the same, but might have different visual representations. So the word give, gave, given, gives, giving should all stem down to give. That way, if I type in any of those words, if I type in giving, I probably want documents to have the word give in it. If I type in give, I probably want documents to have the word giving in it. And so we just boil them down to say, no, you're all the same thing. That process is called stemming. And then we take all that and we build an index. And then we can search, do full text search and find words in documents. This is what Google used to do. This is how we search text before we had AI to search text for us. And it's still a common way. It is fundamentally a keyword search, so it doesn't understand the context of what you're searching. If I type in give, it matches all the variations of give. But that's, if I type in gift, like I gifted you something, or if I typed in gave, those aren't going to match, even though semantically, that's what I would want. Because I would say I gifted you something or I gave you something. It's kind of the same idea, but it's not the same word, and so these wouldn't match in a full text search. Redis does support this. When you create your index, you can just tell it it's text. And then you can just, without any special characters, just put it in there. So I want the observed to have the value of creek. That'll find creek and creeks. But there's a more interesting way to do unstructured text search, and which is to create an embedding. And so an embedding, I'll talk a little bit about what those are after this slide, but process is similar. But instead of getting an index, there is an index eventually, but what we can do is we can effectively turn our text documents into an array of numbers. And in some ways, there's a similar process here. So we may we may take our text document, and in my code that I'm going to show you later, I do this, and you can take it and run it through a summarization model, an LLM, and say, hey, LLM, you're a helpful assistant who summarizes Bigfoot sightings. They must be this long. And don't make them too long, because you get some of these Bigfoot accounts and they're like lots and lots of words long, 8,000, 10,000 words long. But we want something shorter and a little more compact. So we can summarize it and get the essence of that document. And then it gets tokenized, which is to say split up into all its individual words and punctuation. And then you can run this through an LLM or a purpose-built model to create an embedding. An embedding, then the output you get as a programmer, if you run through this process, is I got an array of numbers. And that's all it is. I've got a little array here of 12 numbers. It's usually a lot bigger than that. In my sample application, it's 384 numbers. The cool thing about embeddings is that in addition to doing text and getting things that you can then make searchable, you can also do it with images. So instead of summarizing, tokenizing, and embedding, you're going to run it through some image transformation to say, make sure it's 1024 pixels square, maybe reduce the black and white. You do various image processing techniques that are kind of brute force. You run it through a convolutional neural network. And then right before you get to the point where you would classify it, you just instead get a list of features, which is an array of numbers, which is an embedding. And so that creates an embedding. And you can do the same thing with audio. So you can run audio, and then you can do some pre-processing like noise reduction and that kind of stuff. Again, these work well with convolutional neural networks, and then you create embeddings. If you're curious about convolutional neural networks, I have a talk that I did about that several years ago. I think I might have did on Codepalooza, didn't I? I have a talk called Deep Learning Like a Viking, Understanding Convolutional Neural Networks. I use Keras and stuff, and basically I take handwritten Viking runes and then tell you which one they are. So it's a talk I did several years ago, but those models are used to create these embeddings for images and sound. So that creates embeddings, and embeddings are the magic that we can use to search. But I haven't really said what an embedding is, this, other than it's the magic number array of numbers that I get at the end that I can somehow search on. Well, an embedding is actually a bunch of coordinates. So in this particular example, this would be coordinates to a 12-dimensional space because I have 12 numbers. So on the x-axis, it's this. On the y-axis, it's this. On the z1 through all of them, right? But think about it more easily. You can think about it as coordinates to a hyperdimensional space. I'm going to show 2 dimensions here because that's something we can put on a slide and actually talk about. But the idea here is that words that are related or documents that are similar. I'm using words in this example here because it's easier to talk about. But in the case of embedding an entire document, you actually are creating points for the documents in the space. But we'll think about it in terms of words because it's easier to conceptualize. Words that are related are closer to each other. And so you see up here on the top left, is that coming through up there? That does not work well at all over there. So you'll notice you got Bigfoot, Yeti, Sasquatch, biped, animal. And the closer they are to the thing, like Bigfoot and Sasquatch are very close together. Yeti's kind of close. Animals down here. We got things that are related to the night over here, things to the day over there. Concepts that are related to each other as words are next to each other. Now, these aren't next to each other in a 2-dimensional space. They're next to each other in the case of the model I'll be using, 384 dimensions. Obviously, we can't visualize that, but we can represent them as a coordinate space of, basically it says on this axis, go to 0.72 and then go to 0.86. And you're like if this here represented that space, we just have 2 coordinates. And biped would be like minus 0.4 and positive 0.4. Does that make sense? Okay, cool. And so this is what an embedding is. Now, these are words. We're embedding documents. And so when we embed documents, the AI is looking at the entire document saying, it's a document about this sort of thing. And it puts it here at this in this space. And another document comes along and it's like, this is a document about another sort of thing. And it's similar to this one. And I know that because I'm a large language model and I understand all the words and the grammar and the relationships between them all. And so it puts it in a similar space in the embedding. Words are easier to think about. What's interesting is you can do linear algebra on these. I don't have a slide for this, but if you're actually using word embeddings, you can take the word king, the embedding for the word king, the coordinates that represent the word king. You can take the embedding for the word man, subtract it, add the embedding for the word woman, and then where it points is to the word queen. Because it has created the relationships where that works. And so you can do math on words, which is kind of weird, frankly. Now we're doing this on documents, not words, but the principle is the same. So how do we search? How do we use these to search? Well, if the coordinates are in close proximity to each other, if the ideas are related, if the documents are similar, then the vectors should be similar, right? The numbers in our coordinates should be similar. So here we've got a simple vector search, vector database. I've taken several Bigfoot sightings, turned them into numbers, shoved them into a database. Here we have a young man saw Bigfoot in the woods eating raspberries. It generates one set of numbers. Here you have a witness encountered Bigfoot at Walmart buying size 17 flip-flops, as one does. And then perhaps the best one of all, Bigfoot knocked on a woman's door selling magazine subscriptions. I'm sure we've all had this experience. I actually had watched Office Space and got the idea for that joke. So we've got a database. It's got these 3 Bigfoot sightings in it. Someone comes along and wants to query that database. And so they type in buying footwear. So that buying footwear is also turned into an embedding. Any guess where this is going? What we do is we take that embedding on the right and compare it to all the embeddings on the left, and the one that's the most similar is the winner. And there are various ways of doing this similarity, of seeing how similar the vectors are. Because, footwear is not flip-flop. These are different words, but the related concepts are close to each other, right? So if I'm looking for buying footwear and it's buying size 17 flip-flops, the model that creates these embeddings knows that these are similar things, and it's going to put them next to them. This one is certainly going to come out at the top of the list. There's a couple of ways you can do this. I'm going to talk about two of them that I understand, and there's a third one that I don't understand how it works because I don't have a math background. I'll mention it, and you can look it up on your own. So here's our embedding space again here. And the way that we can determine how similar vectors are is we can measure the Euclidean distance. This is just a straight up draw a line between these 2 points and then find the 5 closest. Those are our top 5 in order. The closest one is the closest match. The next closest one is the next closest match, etc. That's one way. Another way is you can do cosine similarity. Instead of looking at the distance between them, you can look at the angle from the origin. Generally, I think this is how this works. The further out they are, the more specific they are, and the closer to the origin, the more general they are. And so you notice like you got animal down here and then Bigfoot up there. Animal is more general than Bigfoot. Sun and day are, now maybe that's not a good example, but I mean, I just made this up. All right. But the idea is that the Euclidean distance is showing you the magnitude of how far away things are from each other matters more, whereas the cosine similarity is the direction they're at matters more. And so they find different types of similarity. I chose cosine for my model. I think that was a good choice. I could have just as easily used Euclidean distance. You can also do the, I think it's called the inner product or the dot product of your query and all the documents. And that is sort of a halfway between it. The magnitude of the difference matters. So it's kind of like Euclidean, but the direction matters as well. And so it takes both into account. But this is the type of, like, this is really intuitive. My document is this point here, or my word is this point here. Other words near it are probably related concepts. And so you can just measure it. And in the case of cosine similarity, the line coming out from that origin and the other line, similar concepts should be next, the angle should be closer together, whereas more far apart concepts, the angles should be further apart.
Seems like Euclidean distance would maybe get you things that are a little bit more like it's a little bit narrower in a way.
I think that's right, like, because it's going to find things that are of a similar magnitude. Like if you say I'm looking for Bigfoot, then it's going to match Sasquatch, but it's not going to match animal. But if you are looking at cosine similarity, it's probably going to match animal and Bigfoot, because even though the line between them is further apart, they're probably, the angle's narrow. That's my understanding of it. Again, I am not a data scientist. I'm using these tools to do things. So, of course, Redis supports this vector search capability. In case just to be clear, I'm totally a shill for Redis. And so when you create an embedding, when you create an index, this FT create, you can give a type of a field in the schema. Here I'm calling it embedding, except type vector. That means it's going to be a vector, and we're going to see how similar these vectors are. You can specify how the index is created. There are two options in Redis. You can use flat, which is most accurate but least performant, because it basically is a brute force. Just go through everything and build an index. You can also choose HNSW, which is a hierarchical navigable small world. And so this creates a hierarchical graph of the relationships. It's less accurate, but it's a lot faster. I'm not entirely sure how the details of that work. I think it's just subdividing the problem domain. And so you're doing that. It's like a flat is like going through every card in the card catalog in order. And hierarchical is like the Dewey Decimal System. Hey, there's a section here, and then it breaks into this section, and then it breaks into this section. But it can miss things that might be in other categories because things don't always neatly slot into one category. You can give it the size of the numbers in the embedding. This is literally stored in Redis as a protobuf. So you can either use 32-bit floats or 64-bit floats. So floats or doubles. Model that I'm using spits out floats. And so I made it float 32. This is the number of dimensions. dim38 is the number of dimensions. There's 384 that my model spits out, and so that's what I used. Basically, it's how wide is that array. And then the last thing is the distance metric. I mentioned you can use Euclidean, that's L2, inner product, which is IP, and cosine, which is the cosine similarity. And so you can choose which mechanism you want to do. Once you've created that index, you can then call search. And the query is a little weird, but you got parentheses with a star in it. That star can be replaced with something else. If you do ft-search star, and I missed the index name there, it should be ft-search Bigfoot sighting index. And you just give it a star that just returns everything. And so what we're doing is we're saying return everything, and then functionally, like an arrow function in JavaScript, run this embedding search. And so we're saying use k nearest neighbors to find the top 10. You can also do a range query. The field is embedding. And I'm going to give you the embedding I want you to compare it against, and that's going to be in $blob. And then I pass in my params, and there's my blob. And I sort by the embedding score. And the dialect2 is just because this is added to Redis in a future version, and we want to maintain backwards compatibility. So this is basically saying use version 2 of the API. And this will do a search against Redis. The cool thing is that star is actually the query to Redis search. And so you can actually do filtered searches. So you can kind of do all of this at once. And I think this is kind of cool. So here I've created the index with everything. I've got my tags for county, state, and classification. The high temperature is numeric. I've got my geo point. I can search on all those things. I've got my full text search there and in my observed field. And I've got my embedding. So I can create a schema that does all of these things. And I can query on whichever ones I want. So in this case, I'm doing a search on Bigfoot sighting index. State is Ohio, Kentucky. High temperature 75 or higher. The latitude is within 50 miles of Cincinnati. The observed text has the word creek in it. And once I've filtered all those out, hand those over to the vector search, and then we'll find everything that matches what I asked for. So I can sort of pre-filter it and not have to go through as many things. This is called a filtered search. It's not a hybrid search. A filtered search is saying filter out first and then do the vector search on it. The thing is that when you search with full text in Redis, you'll get a score because it's a full text search. Full text search tools do this, and you get a score and like a rank, and it puts it in that score order. Vector search also creates a score. And so when you filter first, the full text score is happening, and then the embedding score happens next. And so it's not bringing both of those together. Like you might actually care, like, no, it's really, really important to have this word in it. Or maybe it's less important as long as the vector. And so you can't combine those scores together, which is what a hybrid search would do. Redis doesn't do that yet. It's coming. It's on our roadmap. I'm not sure what release is planned for, but it's definitely something we are working on. But yeah, that's how you can do structured and unstructured searches all together in Redis. I've got a demo. Do you want to see that this is real? Do you want to see some code? Like he's talked a lot. He showed me some queries that allegedly work, and he's got lots of typos in them because he hasn't done the slides yet before.
I want to see Bigfoot.
You want to find Bigfoot? Let's find Bigfoot. All right. Okay. So I'm going to show you my code a little bit first. I need some slides explaining what I've built, but basically I've built a simple API in Express. Let's go ahead and pull that down there. And if you haven't used Express, don't worry, it's not complicated. You just spin up an app, start the server, and then you basically just say app.post/search. That creates a post endpoint at the root /search, and then any arguments come in on the request, And so here is the query, which would be like, Bigfoot sightings involving intoxicants. And then you can pass in other parameters, such as like state and county and that kind of stuff. My GUI doesn't do that. The API supports it. And you can pass in what you want your count to be. So do you want 10, 5, 100, whatever. We've got a load command or endpoint. The load endpoint is you give it a JSON document with a Bigfoot sighting in it. And that has the ID and the state and the zip code, all the data about it, including the observed. And what it does behind the scenes, search triggers a vector search or a filtered vector search. What load does is it takes all of the data in that JSON document and writes it out to Redis as a hash. But it doesn't create the embedding yet because that takes a while. This is designed to run on my MacBook. I'm using a local model to both summarize the Bigfoot sighting and create the embedding. So there's no API keys in here. There's no OpenAI. You don't have to plop down a credit card. You can run it on your own machine. So you can clone the repo and go, which I thought was really important. I wanted this to be like, you just bring the stuff down. Yeah, it might be slow. Like my MacBook's an Intel Mac, so my GPU wasn't available to any of the models either. So it was really, really slow. And so what I do is I drop the observed account and the ID on an event stream in Redis. And then I have another process that's running that picks those up and processes them and updates the embedding once it's done. And what that process is doing is it's taking the text of the Bigfoot sighting. It is summarizing it. I have instructed it to say, you are a helpful assistant who summarizes Bigfoot sightings. These Bigfoot sightings will be used to do vector search, and they must be no more than 500 words long. And you will be given a sighting. You will summarize it in 500 words or less. And then I handed the Bigfoot sighting. And then the LLM, which runs locally on my MacBook, does that, summarizes it, which takes about 90 seconds on my MacBook. There are 4,586 Bigfoot sightings. I have run all of these already and saved them out to Redis and that Redis file onto disk, and that file is on GitHub. So if you clone this, you don't have to do this yourself. But my computer ran pretty much all weekend for 2 weekends to generate all these embeddings. It then takes that summarization and runs it through another model, which will then create the embedding of the summarized version that's 500 words or less. So all of that happens in load and the ancillary process, which is down here called the embedder. And fetch is the easiest of them all. You give it an ID and it fetches from Redis. It's very easy. So to see how these work behind the scenes, here is save. So we got the Bigfoot sighting here. It's just a JSON document. We get the ID that becomes part of the key name. And then we set all those values in Redis. And if there is an observed field on that sighting, some of them don't have them, then it calls xadd to add it to an event stream in Redis. And then it returns. And that's all it does. The search builds up that query that I was talking about earlier. So here we've got, I look at my parameters. If there's a state, then I do a state search. I append that to the string. If there's a county, I append the county. And these are that curly brace tag text search or string searches. If there's a high temperature that we want you to look for, then we put it in here. You have to pass, if you pass the high temperature, and it's an array low and high for the range. And then if you provide a point, then I build the query for that as well. So we're building up this search portion of the query. If when that's all done, it's got nothing in it because I didn't pass some of these parameters in, then you just make it a star. Then we build up the vector portion of the query. Here at k nearest neighbors, count is whatever you passed in. We want embedding and blob. We put that all together into one string. We then get our embedding model and we embed the query. And I'll show you that bit in a moment too. That's going to return an array of bytes or an array of 32-bit floating point numbers, which we need to convert to an array of bytes. And this is really weird code here because I've got a float 32 array that I want to create from that embedding from what was returned from this model. And then I get the buffer of that float 32 array, which is going to be the actual bytes. Like that turns into an array of bytes. But then I need a dot, and this is like a JavaScript buffer. But then Node has its own concept of a buffer, which is a capital B buffer. And you can hand an array of bytes and it'll create a buffer that it can hand in. So I take it from an array to a buffer, which is weird. It's what I had to do to transform the data and what it needed. And then I can then just run my query here. So this is the query that I built up. Dialect 2, there's my blob, sort by the embedding score, return these fields. And this embedding bytes here is this here. And then I get the results back and it'll give me the top 10 or top 20 or whatever Bigfoot sightings. Fetch is boring. Builds the key, calls hgetall. Don't return the embedding, so I delete that from the return results and then return. From a model point of view, I'm using Node Llama. I'm using two models. There's the embedding model, which if we look in models.js here, I'm using Hugging Face Transformers embeddings, which is a LangChain community plugin. And basically what it does is it goes out, you give it a model name. Here I'm using Zenova All Mini LM L6 V2. I tried several of them until one worked okay. This one worked okay. This is my scientific way of picking a model. And the Hugging Face Transformers embedding, you just give it a model name out on Hugging Face. It downloads it and uses it and it works. And that's really all there is to it. Hugging Face, if you don't know what Hugging Face is, it's like GitHub for models. So people build all these AI models, put them out there on Hugging Face, and you can download them. Or in this case, Zenova's software downloads them on your behalf. So this is actually creating the embedding. This creates an embedding out of my query. So when I type in, Bigfoot buying footwear, then it creates an embedding using this model. The summarization happens in the embedder as well as the embedding. And just to show you how that works here, let's go to, there's app. So this just starts processing things. There's a summarize and embeds that would all be in, where is it at? That going to be in? Probably in embed. Yeah. So here I'm using LangChain itself. And I've got a fetch summarization model and fetch embedding models, which I'm importing from models.js. So the summarization model, the embedding model is the same code from the other one. The summarization model is I'm using LangChain, but this time I'm using Node Llama CPP. So this is obviously using C++ behind the scenes, but it is you can take any models from Hugging Face, download them. And I literally have one sitting right here in this models folder, Mistral 7B. And it'll bring that into memory. The 7B means there's 7 billion hyperparameters. Those hyperparameters are the values and all the weights on the neural network. And there are 7 billion of them, and they're each a 2-byte float, which means 14 gigs. So this model takes 14 gigs of RAM. That's actually a slight lie because it's quantized, which means they've done magic to make the numbers smaller. And so it doesn't take as much RAM, but it still takes a lot of RAM. I'm able to run 4 of them in parallel on my MacBook. But here we can just use Llama CPP, instantiate it, give it a batch size, a context size. The context size is basically the biggest bit of text I can shove into it was a little over 8K tokens. And so that's why that's context size. It means it can handle 8,192 tokens. So if I had longer bodies of text, I would need to increase the numbers, these numbers. The actual embedding is in some ways kind of surprisingly stupidly simple. So I have an instruction template. This is what I tell the LLM. This is programming. You are a helpful assistant who summarizes accounts of Bigfoot sightings. These summaries will be used to generate embeddings for the sightings so they can be searched using vector search. You will be given an account of a Bigfoot sighting, and you will summarize it using no more than 512 words. You will only return the summary and nothing more. You will never return more than 512 words. And then I've got a sightings template. And this is just a little variable there that's going to be swapped out when I invoke the model. So I've got a little command here to summarize. I give it the text that I want to summarize. This is the Bigfoot sighting. And then I say, try to summarize. There's actually a bug that I'm compensating for here. The library would crash after the model was used a few times. And so I found that if I threw it away and recreated it when that happened, I could just do it. So I try to summarize, and I fetch the model and I give it text. And if I get an error, I say, well, fetch the model. And this time, don't give me the cached copy. Give me a new one and give it the text. Either way, what I'm really doing behind the scenes here is I'm using a chat prompt template, which is part of a Lang chain. And I give it the from messages, and from the system, that'd be the software. Here's the instruction template. You are a helpful assistant. Here is the citing template, which is just the word citing in curly braces. And then I pipe that into a model, and I invoke it, and I give it an argument named citing. And all it does is it takes the text here and puts it here. That's all it's doing. So basically, I'm telling it, this is what you are. Here's the text. And then to embed, I just call embedding model, and I call embed query. And the embedding is actually a piece of cake compared to interacting with the LLM itself. The summarization is what made this hard. So that's pretty much what I've built. Is there anything else in here that's worth talking about? Probably not. The front end stuff, you don't care about the front end stuff. It's all JavaScript that no one wants to see. Let's see what we got here. So let's go ahead and Docker compose up. Okay, so Docker compose up brings up my API. It brings up my Redis instance, brings up the GUI, brings up a gateway, brings up everything. And if I go out here to there, and we'll just make sure this is running. It is. Let me embiggen that a little bit. Is that better? I think that's a little better. And we can search for Bigfoot sightings. There are 4,586 of them. What kind of Bigfoot sightings should we search for?
I'm curious about the ones involving intoxication.
All of them.
Involving intoxicants. You don't get as many of those as you would think, but there is one here. Young man sees a huge hairy ape-looking thing under a bridge on the Scioto River, which that would be in Ohio, probably. A witness, and so two things worth noting here. So the summarization model is summarizing the sighting. So this is the eyewitness account down here. Here's the word drugs. And they said, holy something, and they hauled something up the side of the bridge. I'm not sure what that is. But this is the summarization that the LLM running on my MacBook, which is about 3 years old. It's got 32 gigs of RAM. Intel. I mean, it's a beefy machine, but it doesn't have a GPU that the model could use. It summarized this as a witness recounts an encounter with a large hairy creature while walking home near a bridge around 9:45 p.m. They had a splash in the river and went to investigate, only to find nothing on the bank. Upon entering the water, they saw a large ape-like being standing in the middle of the shallow river. The creature made a gurgling noise and started running towards the witness, causing them to flee in fear and sustain an elbow injury. Despite their belief in the authenticity of the encounter, their mother dismissed it as drug use. Since then, the witness has avoided crossing the bridge at night due to fear of the creature. They urge others to take their account seriously. So the two things that are interesting here is, one, this was generated on my MacBook. I can't stress this enough, right? An AI running on my MacBook generated this. It reads really well. Two, it almost always, I asked it to summarize it, and it takes the eyewitness account, which is in the first person, and summarizes it in the third person fairly consistently, which I thought was an interesting phenomenon. So yeah, there we go. A hairy ape looking thing under a side of bridge. There's eyewitness account. Here's the location. That's in Hardin, Ohio. We can see where that's at if we click on the little Google Maps link. There's the Scioto River. And that's northwest of Columbus, a fair bit. And then I went to more trouble than I probably should honestly have to make the weather report look really nice. but there we have it. Now I've told this to just return 10 no matter what. And so there's not a lot of them in there that mention drugs or other intoxicants. And so as we go down, it doesn't work quite as well because it's like, well, this is the next closest thing, right? You can combine concepts like near a body of water at night. Two boys see a large animal wading in pond near Morton. As darkness fell, duck ponds. This one did not get turned into a third person for whatever reason. During night, a camper heard vocalizations. This doesn't mention water, so it's a little. I'm not a data scientist. The Lake George Adirondacks. And so the one I thought was really interesting, and I found that as I added more documents, it actually the accuracy dropped a little bit in this example app. When I had a few in there, like I said, show me the ones that happened in the desert. And the first hit I got, it was really neat. It was in the desert, but it didn't mention the word desert at all. It mentioned washes and cacti and things that are in deserts. And the LLM knew that was desert related. And so it got put in a place in the embedding. The coordinates were such that it was desert related. So in the desert. Well, it's a place called White Sulphur Springs. That definitely sounds like it's in the desert. Arizona. That's definitely a desert word. And so it can pick up clues. When the data set was a little smaller, I also, one that kept coming up was for near a body of water at night. It ranked first this account of people who were at a barn. They went to a barn on their property out by the lake to watch movies, and then they heard something. And they went outside and looked around with flashlights and couldn't find it. And it figured out that because they were outside with flashlights, that meant it was dark. So it's able to pick up those context clues and categorize it. It's really quite neat.
Actually, could you use the map to search as well? Like, you're saying like desert or body of water, could it do that based on the map?
The embedding wouldn't necessarily know about that. I found that it doesn't seem to know geography. The LLM that I use or the embedding model I use doesn't seem to know geography very well. Like sometimes it does. Like it's like it picked up that White Sulphur Springs sounds like the kind of thing that would be out west in the desert. And Arizona came up, but if I ask it like say in Kentucky, right? Oh, actually, this did find Kentucky. This is a resident. No, I'm not surprised by that at all. Although Ohio has more, so just saying. Maybe it's still a little bit better here because in rural Tennessee, which is next to Kentucky, and so. Although honestly, looking for Kentucky would be better using a structured search, right? Because we have a field that says Kentucky. Boone County, Missouri. There is not that's not that close to Kentucky. I don't think. However, I know Boone County. There's a Boone County in West Virginia. There's probably a Boone County in Kentucky too. Yeah. Oh, did I? Okay.
I actually kind of wonder about the White Sulphur Springs one because,
it sounds like a desert place name, doesn't it?
But it's at least the one that came up in Google search showed up as West Virginia.
Huh.
Well, because when you think about it,
that would make sense too. Yeah.
Hot Springs.
Yeah. Now, what would be cool is I could add like the structured search. So I could say, well, drop downs and say filter at this, and then, but I didn't put that in there because I was lazy. And partly because this is a code-based design for someone to take and expand upon, and so that's a good exercise for the user as well. But yeah, let's go ahead and do another thing here. So I'm going to kick off an embedder. So the easiest way to do that is just to do an npm start. And that's going to spin up an instance of that LLM that's going to do the summarization. And it's going to spin up an embedder. And then it's just sitting there. It's watching an event stream in Redis. And when a message pops up, it will pick it up and process it. So we're going to do that. So you can see it's not finding anything, right? But if I go in here and do a conveniently prepared one, we're going to post a simple one. Here's an ID of 65535. I saw Bigfoot at Walmart buying flip-flops. Apparently he wears a size 17. That's going to happen in Athens County, Ohio, which is where Athens, Ohio is at. It's on the West Virginia side of Ohio, not the Kentucky side of Ohio, so we can make fun of them. And it's a class A because we saw Bigfoot, and I gave it a timestamp, which is the date and time it happened. It's just the number of seconds since the beginning of the epoch. If I enter here, I added to the backlog for summarization. If I go into, do I have Redis Insight running? Let's launch Redis Insight so we can see what this looks like inside of Redis. That's our new logo. Okay, I'm going to go to that local one. Let's expand this out. I'm going to go to key types. We're going to look at the stream. And this is an event stream that I plopped it on. So here is the one I just dropped in. I've done this before, so you see, right? There's when the event come in. This is the ID that I gave it, 65535. I saw Bigfoot at Walmart buying flip-flops. Apparently he wears a size 17. So this is on the event queue. If we go here, we can see that it picked it up and is processing it. It processed the event, acknowledged it. So it's summarized that Bigfoot sighting and created embedding. So we should be able to go into here, into Redis Insight, go back to the browser, and we'll look at hashes. Let's just look at all key types. And we'll filter for Bigfoot, sighting, 65535. There it is. Here's all the fields, Class A, Athens, ID, timestamp. There's the embedding. It's just binary data, right? So it's just garbage. Well, it's not garbage, but it's meaningless to humans. And then here is the observed. I saw Bigfoot at Walmart. Here is what the AI has summarized that as. I love that when you give it something short, it actually expands it, like a middle school student writing a book report that must be 500 words. In this account, a witness reported an unusual encounter at their local Walmart. They claimed to have seen Bigfoot, a legendary creature often described as a large, hairy humanoid, purchasing flip-flops. The size of the footwear suggested that Bigfoot had an unusually large shoe size, estimated to be 17. This sighting is intriguing due to its unexpected setting and the potential implications for understanding the habits or needs of this elusive creature. It literally just made that up right now. That's so delightful. And it's got an embedding, which means we can search for it. Let's say purchasing footwear. Is that how you spell footwear? W-E-A-R. There. It's not hardware. It's footwear. Totally different. Totally makes sense to those are spelled differently.
Of course, it would be interesting to see if it would actually still manage to figure it out.
We should try that, actually. We'll try that next. But it did find it. And there is our account. You see we don't have any weather information. And it expanded it out. Let's purchasing footwear. It still came up second. It probably took foot and wear and treated them as two tokens, because sometimes it'll split words apart like that. But it still came up second. Let's see, shopping at a big box store. There it is. What's the second one here? While on a Bigfoot sighting expedition, a group of individuals encountered an experience near Fort Christmas, Florida in East Orlando. Of course, it happened in Florida. After driving for over an hour, they spotted something large running out from behind a tree. Nothing about shopping there. I wonder if it picked up the word Christmas
That's what I asked.
and associated it with shopping, which would not be totally crazy. Here's one up in Cleveland in the Cuyahoga National Recreation Area. So, well, yeah. So this is my fun application. It's kind of silly, kind of stupid, but obviously you don't need to find Bigfoot sightings in your job, but you could see how you could use this for other things would totally be relevant to your job. We all have a need to search documentation, and you can use these same principles to search images and to search sound as well. So one of the things I hope to build is I want to do a meme matcher. So I want to take all the popular meme characters and create embeddings of them, and then take a photo of someone during a conference talk. Arissa would be happy to volunteer, I'm sure. She'd come up here and pose and be Success Kid. Or, maybe we can tease Chad's hair up and he could be that aliens guy.
I feel like that ended up coming up as like I've seen a bunch of I've used this in like my D&D game, like the screaming possum meme.
Yeah.
I feel like I'd be more likely to look like that because I'm always internally like.
But I think it would be so much fun to just like be able to take photos and say, which meme character? Because no matter what happens, it's going to be funny. Unless you're like the SpongeBob one where he's all weird, sarcastic SpongeBob.
I wonder on like the searches because you're using the cosine.
Yeah, a Euclidean might work better for what I'm doing.
See, I kind of wonder like on the one like the big box store and stuff like because like I could see cosine like getting that distant relationship between Christmas and like shopping. And I wonder if you would still see the same thing if you did like
We should try that sometime. Not going to try it tonight. Now you all are welcome to fork the repo and try that as well. There are models out there that will create embeddings that are multimodal. These are fairly new and experimental, and mileage will vary. But you give it text, it creates an embedding. You give an image. And if the image and the text are in alignment, the embeddings will be similar. And so you can take text and find images that contain those things, or take an image and find text that describes it. And so those are interesting and new and kind of bleeding edge. Once you know how to use these vectors and embeddings to search things, there are patterns that you can use beyond that. So you've probably all heard this, right? This is a hot term, RAG, Retrieval Augmented Generation. This is, anyone familiar with this? Made use of it? This sounds big and fancy. It's actually not all that big and not all that fancy. It's fairly straightforward once you understand how vector search works. So what Retrieval Augmented Generation does is, I've got someone who has a problem, a customer maybe, and they're asking, why do my photos keep coming out blurry? It's because you're Bigfoot and you're blurry. And so you can take that question and create an embedding. And then you can take a whole bunch of documentation that might answer that question. And you can put it in a database like Redis and store the documents and store the embeddings. And then you can search like we just described, and you can find documents that might contain the information they want, one or more documents. Then all you do, so you query it, right? And you take those documents and you hand them to an LLM. And you take the query, not the embedding, the query itself, and you hand it to an LLM. And then you just put them together and ask a question. Given the following context, here's my documents. You're literally just stringing this text together. Given the following documents, colon, and then text of document, text of document, text of document. Answer the following question, text of the question. And you hand that, it's like if you just typed all this into ChatGPT. And then it will look at everything it was given. And it's been instructed, don't look at anything else, take only what's in these documents and answer this question. And in effect, it lets people find documents that might answer the question, and then they can interrogate them. And so this is this solves a fundamental problem, which is your large language models don't know everything. Like you have a bunch of information in your company that probably, I hope it's not in ChatGPT, right? But you need that large language model to have that context to answer a question. Well, you can go out and get the context using vector search and then hand it off along with the question. And then it will let you, in essence, let you make your documentation, you can ask questions of your documentation. And this is cheaper than building a model that understands your problem domain. So this is one pattern. It's not really that hard to imagine what that code would look like to do that, because you're literally just doing what my example just did, and then building a query and handing it off to ChatGPT through an API or a local model running on your MacBook like I did. And that's it. Another pattern that is popular is semantic caching. So someone asks a question of a large language model or of a RAG. You can cache those results, even if the question isn't exactly the same. So again, someone's asking the question, my photos keep coming out blurry. Create an embedding. Redis is out there operating as a cache, which is a popular use case for Redis. You go out and do vector search and say, hey, has someone asked this question or something similar to it, and what's the answer? And you can look at the score you get back and decide whether it's close enough or not. And if it's close enough, you return the cache content. Now, someone might have said, my photos keep coming out blurry, or I have a problem with blurry photos, or I'm taking pictures and they're all fuzzy. And all of those would generate similar embeddings, which would retrieve similar documents. And so regardless of the question they ask, you can return cached content as long as it's similar enough. If you don't find anything, then you can go and ask your expensive LLM that question, return the results, and cache them and create an embedding. So the next time someone asks it, you don't have to. And that LLM doesn't have to be an LLM. That LLM could totally be a RAG example. So you could semantically cache the results of your RAG. So you don't even have to go through that process to go to the LLM. So these are a couple of patterns in addition to the semantic search example that I started with that you can use with vector databases. So that's pretty much what we got. Here's the link to the code if you want to play around with this. This QR code will take you straight to the code on Redis Developer. Slides aren't out there yet. I got to figure that out. But if you want to play around with this code because you want to do JavaScript like me and be sad and cry at night, then you're welcome to. There's no reason why this wouldn't work on .NET. I just use JavaScript. You should be able to use semantic kernel to do similar things, I'm told. You can certainly talk to Redis from .NET and execute all these commands that are against Redis. So I hope to create a port of this for C# and for Java at some point, because Java would make me even sadder than JavaScript. So that's what I've got. Are there any questions? Everyone pretty much asked them in the moment, but if there are any questions before we wrap it up.
Could you point out like a document repository or something that had like pull all the documents in without?
And you'd have to write code to do that, but yeah, you could totally do that. The question for posterity here is, could you point this at a document repository? Yeah, I mean, you could basically just tear through all your documents and create embeddings and put the embeddings in the database, and you could even just in Redis, you could even just have a pointer to the document repository. You wouldn't even necessarily need to put the document itself in there. That might make more sense one way or the other. Problem to solve, right? That's an engineering problem to solve. But yeah, you could totally do that. Now it's got to be text documents for the particular example. So if you've got documents that are like a bunch of signed forms and they got graphics and stuff in it, that's more complicated. But if you just got basically like a bunch of Word docs and you just care about the text, or a bunch of markdown files, yep, you can totally do that. I love it when the answer is yes. And not yes, but.
I feel like a whole other sort of, I like medical research and stuff like that. And just like cases where you could use this load up. Now this is probably going way too far, but something like PubMed, for instance. Like points relates to PubMed where you can ask it, like logical questions. Show me all the cases that have like, I don't know, Burnett's with cancer, for instance, or something crazy like that.
Yeah, I wouldn't be surprised if they're working on that kind of stuff. Honestly,
I know, I know a few different companies. But that's like the big thing that they do is like trying to comb through like medical records to, like there was one Lucina Health. I think they got bought up by someone else here not too long ago. But like they were doing ones where they would look through medical records to try to identify pregnancies where there was like a higher risk of premature birth.
Yeah.
Because those are so much more expensive, and so you can get ahead of that and identify the ones that are most likely to potentially save like millions and billions and lots of lives.
There you go. Get the insurance companies involved.
Oh, they're looking at this
Oh,
stuff.
yeah.
Like, I think like the VA has been doing one where they're trying to identify like veterans that are at high risk of game over. So yeah.
Well,
Try to help save people there too.
but it's got enormous potential. And the nice thing is like all this stuff doesn't have to cost money. You can play with it as a developer for free. Like I was really trying to do three things with this repository that I built. I was trying to show, you don't have to plop it down a credit card to use a bunch of expensive APIs. You don't really need to understand them in great depth to be able to use them. You can just string them together and do reasonably impressive things. And you don't have to do it in Python. I did it in JavaScript. That's like the worst language to do this, right? But you don't have to be a Python developer to use these things either. So they are accessible on lots of platforms. And just as developers, we can string these APIs together and build rather impressive things. I personally think that, like, I know there's a little bit of a tech recession right now. I know a lot of us are feeling that. There's probably people in here that are like, oh, I'm here to network in case there might be work. If you're in that scenario, I hope you find something. But I really do feel like a lot of this AI technology it reminds me of when we had the big mobile boom about 10, 15 years ago. And it reminds me of when we had the big internet boom about 10 or 15 years before that. These are big seismic changes in how we build software. And they were more software, not replacing software. So when the internet boom happened, everyone needed a website, but all these enterprises still had all these applications that were required to keep the business running. And so they just needed more developers. And I remember my first job out of college, I was making $28,000 a year, which is less than you would make at a fast food place now. But I was very happy to make that. I thought I was rich. And by the time 2000 came, I was making $68,000 a year. That was in 6 years. That was a nice boom to go through. And then we had another cycle of that around 2008 when mobile happened. I know 2008 was when everything plummeted, but at the same time, you needed all these mobile developers, but the websites were still there and the apps were still there, as in the enterprise apps. I think we're at another one of those moments now where we need AI applications, but the web apps are still there and the mobile apps are still there and the enterprise applications to keep the lights on are still there. And so we just keep adding software without subtracting it, which means we keep adding developers without subtracting them. And yeah, we're in a recession right now, a tech recession right now, but it'll pass. And I think this will, hopefully we can ride this until I retire in 10 years. That's my goal anyhow. So that's my little beam of hope and say, this is cool. And I think that there's a lot for us as developers to do with these tools. There may come a point where these tools are doing all of our work for us, but I've seen the code that I get out of ChatGPT and Copilot, and sometimes it's clever and it really follows me well, but it's like a really, really good IntelliSense. And sometimes it's like, no, that's not what I was thinking at all. And so it helps me and it makes me faster, but it doesn't replace me. So that wasn't a question, but just sort of what it ended up. So here's my final, I think this is penultimate slide. There's my contact information again, if you want to go check it out. And yeah, there's a slide that they put in my deck. See how fast feels. That's all I've got. So thanks a lot.
Great, thanks.
All right. Well, Guy, again, thank you so much. Like I said, so those want to join us, we're going to go over to Brick House. Yeah, you all know where we're going.
How long did I go? I went a little long.
Yeah, about an hour and a half.
Yeah, I need to tighten it up.
Well, for you, that's a good time. But
For meetup, it's okay. I hope it didn't go on too long for y'all. So.
I think that's about